Hello and welcome to this presentation on microwave passive components. Myself Sanjit Kumar Singh, lecturer in Electronics and Telecommunication Department at Praveen Patil College of Diploma Engineering and Technology. The second chapter, microwave passive components, is allocated 12 marks out of 70 and 8 hours of lectures. Topics to learn in this presentation are multiple junctions, working principle and applications of the E-plane, H-plane, MagicT and Ratrace Ring. Rest of the topics like ferrite components, directional couplers and microwave antenna will be covered in the forthcoming presentations. So unit outcomes, what are the outcomes expected? First, describe with relevant sketch operation of the given microwave passive components. Second, describe with relevant sketch the working principle of the given ferrite components. And third, describe the procedure to build or prepare the microwave test bench with the help of the given microwave accessories or components. And fourth, explain functions of the given parameters for the directional coupler. Course outcomes expected is to maintain passive microwave components and devices. Here are some of the components: the multiple junctions, the antennas that we will be covering in this chapter or unit. So first topic, multiple junctions, the working principle. So there arises need to combine two or more signals, or sometimes to split signal into two parts or more parts in waveguide system. So some form of multiple junctions are needed, and this is done by the T's in the simple forms, or for more complex junctions hybrid T or hybrid rings can be used. Besides being waveguide junctions, these components also have other applications. So on the right hand side we see different types of the waveguide T's. The first is the E-plane T, where E arm is drilled on the collinear arms, attached to the collinear arms. Then the H arm, second diagram, H arm, where H arm is attached to the collinear arm along the magnetic field lines. And the third diagram is of MagicT, where we find both E arm and H arm attached to the collinear arms. So first of it, E-plane T. So E-plane T is also called a voltage or series junction. As we can see, the E-plane T actual figure and its transmission line equivalent on the adjacent figure. Junction is symmetrical about the central arm, that is the E arm. Signal which is to be splitted up is fed to the E arm, and we obtain two equal halves at the collinear arms, or combined signal is taken from the E arm when inputs are fed from the collinear arms. The two side arms are called collinear arms. So what are the how it is operated? So for instance, when signal is given from E arm, the vertical arm we see in the diagram, it is splitted up into two equal halves but out of phase. You can say the arrow marks. On one side, say port 1 side, it is downward, whereas on the port 2 side it is upward marked. That shows the phase reversal. Then in the second diagram we find when two signals are fed from two collinear arms of equal magnitude and same phase, then these two cancel each other at port 3, that is the E arm, and hence no output is obtained at port 3 or E arm. The fourth diagram, here we see the two inputs from the collinear arms are equal in magnitude but out of phase, so we get combined output, and the output at E arm is combined magnitude of the two inputs from the two collinear arms. Then in the next middle diagram, right hand side, we see when an input is given to one of the collinear arm, then output will be obtained at the other collinear arm. Say when input is given from port 1, output is obtained at port 2, the collinear arm, as well as on the E arm. Next is the H plane T. In H plane T, hole is drilled along the H plane, that is the shorter dimension, and an arm is attached called the H arm. All three arms, the collinear arms, collinear ports 1, 2 and the E arm 3, are all these three arms of H plane T lie in plane of magnetic field. That's why it is called H plane T. It's a current or parallel junction we can see in the figure down. It is symmetrical about central H arm. So if we draw a line in the middle of the H arm, then it will divide the two collinear arms into two equal halves or two equal parts. Signal that is to be splitted is fed from the H arm, say with the arrow head upward, will be splitted up into the two collinear arms into two halves. Or when two signals of equal magnitude are fed from two collinear arms, combined output will be obtained at H arm. So what is the application? H plane Ts are used for impedance matching or for splitting, as most of the multiple junctions do. Hybrid T junctions or MagicT. Hybrid T junctions is formed by joining an arm to either of the T junction, that is either H arm or E arm is attached to the T junction. Junction is symmetrical about an imaginary plane bisecting E arm and H arm. So if we draw a line, a plane line cutting E arm and H arm equally half from the middle, then the two halves are symmetrical to each other. So MagicT or hybrid T has a very peculiar characteristics or properties. That is, first one, the E arm and H arm are both connected to arms 1 and 2, that is the collinear arms. Both E arm and H arm are connected to collinear arms but not to each other, means H arm is not connected to E arm and E arm is not connected to H arm. A signal entering either from port 3 or port 4 is divided in between two lateral arms, arm 1 and arm 2, if they are correctly match terminated. So from transmission line viewpoint, the arm 3 sees an open circuit in place of arm 4, and across this infinite impedance, it also sees two correctly matched impedances in parallel. So when a signal is fed from, say, E arm with the red lines in the adjacent figure, we can see at the two collinear arms, port 1 and port 2, the output are out of phase but equal in magnitude, and when signal is fed from H arm no output is obtained at E arm port 3, but is divided into two equal halves at the two collinear arms 1 and 2 with same magnitude and same phase. Next, so where can we use this MagicT? Think for a while, then we return. Okay, so MagicT can be used as a power combiner or divider. So it is also called 3 dB coupler or divider. It can be used in front end microwave receiver as the adjacent diagram shows. As a duplexer it can be used, as a mixer MagicT can be used. So in the adjacent figure we can see when a signal is received by the antenna and is forwarded to the further circuit to the MagicT, the one of the collinear arm is port 1 is match terminated with its characteristic impedance, and the other arm port 2 is having that is mixer circuit. So the local oscillator output at port 4 is generating signal and is directed to port 2, and as well as the signal from port 3 from the antenna is given to port 2 where mixer is there, and these two inputs from the antenna and from the local oscillator fed to the mixer will produce the intermediate frequency output, that is down converting the received signal to intermediate frequency level. So this is done using MagicT. Then Ratrace ring, this is also hybrid ring. The arrangement we can see, it consists of a rectangular waveguide that is bent in the E plane, that is the longer dimension of the rectangular cross section, to form a loop whose median circumference is 1.5 lambda p, where lambda p is what? The wave that will be propagated inside. So this Ratrace ring has 4 orifices or holes or bores. Separation distances as shown in the figure. So what are the separation distances? From port 1 to port 2 lambda p by 4, port 2 to port 3 lambda p by 4, and port 3 to 4 lambda p by 4, 1/4 of the wavelength, and from port 1 to port 4 it is 3 times lambda p by 4. So it has a special property. That property is, if there are no reflections from the terminations in any of the arms, any of the ports, any one arm is coupled to two others. Any one arm is coupled to two others, but not to the fourth one. Very important, not to the fourth one. Fourth port is isolated. So Ratrace ring, when a signal is applied to arm 1, it will divide equally with half of it traveling clockwise and the other half anti-clockwise. The signal reaching port 4 will cover the same distance whether it is traveling clockwise or anti-clockwise, and addition of these two signals will take place at that point 4 and resulting in some signal traveling down arm 4. Similarly, a signal reaching the input of arm 2 from 1, when we are feeding from 1, it will reach port 2 in the clockwise manner, traveling a distance of lambda p by 4 if it is traveling clockwise, and it is traveling 1 times lambda p by 4 in the anti-clockwise direction, because 3 lambda p by 4 plus lambda p by 4 plus lambda p by 4 will be 1 into 1 lambda p by 4. The two portions of signal will add at that point at port 2, and propagation down arm 2 will take place. The signal at the mouth of arm 3 will have traveled a distance of lambda p by 2, half the wavelength, going clockwise, and in anti-clockwise it will be lambda p. So no signal will be entering port 3 as they cancel each other. In a similar way, it may be shown that arm 3 is connected to arm 2 and arm 4, the adjacent ports, and not to the fourth one, that is port 1. So it is the seen that behavior is very much similar to that of the MagicT, although for a different region. Applications. What are the applications? The applications of hybrid T or hybrid ring. The first, the Ratrace and the MagicT may be used interchangeably, with the latter, the MagicT, having the advantage of a smaller bulk as compared to the Ratrace, but the disadvantage of requiring internal matching. This is not necessary in the Ratrace if the thickness of the ring is correctly chosen. The hybrid ring seems preferable at shorter wavelengths since its dimensions are less critical. So here is at last the summary of what we learned in this presentation about the multiple junctions, of its working principle, and the applications we saw of E-plane, H-plane, and MagicT and Ratrace ring. The three types of the T's, waveguide T's, the E-plane T, H-plane T, and down the MagicT. And then we also saw how the signal fed to a MagicT either from E arm or H arm is splitted into two halves into the collinear arms, or when input is fed from the collinear arms, output is obtained at the E arm as well as H arm, with a special property that E arm is not connected to H arm, but both are interconnected with 1 and port 2. Then we saw the Ratrace ring, hybrid ring, which is very much similar to MagicT in its operation, but construction is somewhat different, where signal entering from port 1 is coupled to its clockwise port 2 and anti-clockwise port 4, but not to the fourth one, that is the port 3. Similarly, port 3 is connected with, coupled with port 2, adjacent port 2, and the other side adjacent port 4, but not to the port 1. Learning resources we can go through for further readings. Thank you very much.